And welcome to a Space Universities Network webinar. We're really excited today to welcome Steve Greenland, who's going to talk to us about Craft Prospect. And I'm just going to do 2 slides at the beginning to explain to you what the Space Universities Network is. And that is a group of people who are all staff who teach space in higher education. I'm afraid students can't join this organisation, but it is there to benefit students, and that's why we're organising these webinars, which are focused on illustrious people from industry who come and explain to us what it's like in the space industry. So the people, so on the screen you just have the people who are organising the Space Universities Network. We have here a list of universities who are members. If you don't see your university on there, then please let us know and we will reach out to them and invite them. Membership is free, but again, this is to support staff in higher education. Our aim is to produce skilled graduates. We try and share best practice. We try and make our curricula relevant, and we try and promote space and science and engineering as a career. We do that by drawing attention to the various courses that are out there, both short and long. We have a big resource bank of shared class resources. We have case studies on how to apply for various competitions and to run exciting activities within the teaching curriculum. And we have various meetings and events, as well as some outreach and careers advice. Anyway, so I'm very excited to pass on to our coordinator, who's now going to introduce our speaker. Thank you.
Cool. Hi guys. So we're very lucky to have Steve Greenland here today. Steve is Managing Director of upstream space technology company Craft Prospect and co-founder of the downstream data social enterprise Omanos Analytics. Craft Prospect is a future-looking space engineering practice, giving engineers the opportunity to lead on complex payload and mission systems development in onboard intelligence and quantum communications. Omanos Analytics removes the barrier for accessing and understanding space data for communities in hostile and low infrastructure regions. Prior to establishing these businesses, Steve was the lead engineer on UCube-1, Scotland's first satellite and the first CubeSat developed through the UK Space Agency. This presentation will give a personal perspective on the journey to build a satellite first, and a business highlighting the challenges, opportunities, and considerations for those entrepreneurs in the new space industry. The structure of this webinar will be about a 30-minute talk from Steve, and then we'll open the floor up to you guys for Q&A. So please remember to put your questions in the chat. Just so you know, this is being recorded, and that also includes the chat. Now I'll hand over to Steve.
Well, thanks, Charlie, and thanks, Lucy, for inviting me along. Yeah, so I am Steve Greenland. I've been in the space industry now for about 15 years, and this is a fairly personal kind of perspective on what's changed within the UK in that time, and kind of an account of how I ended up where the fortunate position that I've ended up in. So yeah, please ask any questions, and I'll begin and try and keep it to 30 minutes. So we're cramming 15 years into 30 minutes. Let's see how that goes. And the first challenge, yeah, is just to acknowledge the 3 different organizations whose pictures I may be using throughout this slide. So I started my career as my first work was at Clyde Space. I joined when the company was eight people working on the first satellites there. And then I was fortunate enough to be in a position that I could set up two businesses, Craft Prospect and Omanos Analytics. But just to say, all the opinions and the mistakes within these slides are all my own and nothing to do with the organizations themselves. So my own project lifecycle, I graduated in 2005 and was kind of looking around to see what I could do. And I was fortunate enough to stumble upon in the back pages of New Scientist a small little advert that said, why don't you go and study out in Japan? And I'd been keenly interested in Japan because of the very small satellites that were getting developed there, the first CubeSats, and together with Stanford University and Cal Poly in the States, then they were kind of leading the charge in that. Then I managed to come back to the UK and started looking at how we could embed that kind of CubeSat methodology into our practices here. And that culminated in the launch of UCube-1 in 2014. That was fairly an intense process. And so I spent two years or so kind of reflecting on that and kind of decompressing from that experience. And then from 2017 onwards, I took a leap into the unknown with my own entrepreneurial businesses. So I'll give you a quick kind of summary of that. Within that, what I've found, mistakes are inevitable. Success is just not repeating those same mistakes. And some things, no matter what you do, just remain constant. And I'll try and kind of cycle back to that at the end of the presentation with my conclusions. So as some of you will know, 2003, the first CubeSats were proposed and launched. They came from Stanford University. Professor Bob Twiggs proposed as a means for education, building on the idea that you could build a very small satellite protected within a pod, a deployment system attached to a launch vehicle, which meant that it didn't pose risk to the primary launch. And a number of different universities kind of signed up for this. And as a kind of an avid reader of space technology, while I was based at Manchester University, I saw that Tokyo was doing this and kind of was fortunate enough to reach out for them. So I got the chance to kind of see this satellite, Psi-5, in operations and worked on that, and just looking at kind of how we could use these very small satellites, still fairly primitive, but with a fantastic amount of potential. And for a systems engineer, the idea that you could understand the full system because it was so small and because the technologies at the time were fairly simple. That's changed now, of course. That really helped drive me forward. And so then I was fortunate enough to meet my first employer, Craig Clark, who was setting up a business called Clyde Space in Glasgow, as he was a supplier into one of the space missions we were working on in Japan. And he mentioned that he was interested in kind of setting up something very similar back in the UK. And whilst I'd never been to Scotland, I kind of leapt at the opportunity to come back. And was fortunate enough to end up in Glasgow, which for those of you who are based here, I think there's a few people in the audience. It's a fantastic city to live and work in, with the Highlands so close. Not all plain sailing at this point. We were trying to do something for the first time, and as a very naive young engineer, got a phone call one day from the Daily Mail. And we just started publicizing the work that we were doing. At the time, I think the mission was called ScotSat rather than UCube, and they were a little bit in what I thought kind of awe of trying to do CubeSats in Scotland. They weren't, of course. They were looking for an interesting story, and they managed to couple my own comments with this picture. So yeah, just take care whenever you get a phone call from the Daily Mail, please. But what we were trying to do within Clyde Space is kind of move from building small power systems, which the company was based in, to building kind of complete bus systems. And as many of you will know, that's now been achieved. And what I thought in coming back to the UK and doing this, well, it's I've got 2 years of funding. At least this won't take too long. This is like a really exciting thing for me to kind of jump onto. I started writing the proposals, started mocking up different models, and we got quite far with that. trying to play on the ScotSat element. I'm, as you can probably hear, from England, but as you all know, there's a fair amount of independence movement within Scotland, and so therefore kind of building on that. And at the time, the leader Alex Salmond was quite on board with seeing a Scottish space industry emerge. There was no support from ESA at that time. CubeSats were just seen as these playthings for universities. Again, that's changed, of course, and there was no space agency in the UK, and the small satellite industry was essentially Surrey. So we got quite far, but not quite far enough to get anything off the ground. And it wasn't until then that we realized quite how long the task was ahead of us. What we learned was that we needed some champions within industry, and we were very fortunate enough to be backed by Airbus. Again, it's gone through name changes. At the time, it was called EADS Astrium, and we created something called the CubeSat Research Network to form an initial organization of those universities and industry in the UK that would be interested in using CubeSats, and use that to engage with the British National Space Centre, which was the precursor to the UK Space Agency. We were very lucky. We managed to get a small feasibility study, some tens of K, to start looking at how we could develop a small computer system with which some of the universities could develop payloads which could be plugged in on one side, and us as industry could be used to interface into the first bus systems for these CubeSats. At the time, we had kind of a very noble vision of many satellites being launched in quick succession. There wasn't obviously the money for that, or the appetite for that at the time, but it shows how kind of things kind of take a lot of time to kind of build up. So we had the idea of multiple payloads being developed. They would then be plugged into numerous platforms being developed at different industry and going through into launch. And in 2010, we were very fortunate in that one of the last acts of Gordon Brown and in his government was that we were able to form the UK Space Agency, and that was preserved by the incoming government, as it was always seen that space is good news, and therefore we can use it in many different ways. So what that did is that made it quite easy for decision makers to sign off on our proposal for the first CubeSat. What we were looking to do was to show innovations in UK space technology, trying to show that useful science could actually be performed in some of these CubeSat small satellites, and I think that's been adequately demonstrated now multiple times, but at the time there was a fair amount of skepticism that we could work in consortium between industry and university to build training programs for spacecraft development, that there would be these benefits in science, technology, engineering and maths, and that we could reach payload kickoff to flight readiness in 12 months. And it's always the last one there that makes me cringe, given the timelines as it actually transpired. But in order to do things, then you need to be a little bit naive and just kind of take things by the horn and kind of get things going. So that's what we did. And it was in Farnborough 2010 that the science minister, Mr. Willits, Dr. Willits perhaps, decided to announce that there would be a CubeSat being promoted by the UK Space Agency. We got 3 days notice, and so I very hastily built the model that you can see on the left there, which then ended up on display as kind of a system, but it is essentially just cardboard and some rather nice photographs of solar cells rather than being solar cells themselves. So at times then you do need to play a little bit of a marketing game just to get things moving in the first place. And so out of this kind of vaporware as it was, then we started to actually build momentum. We opened a competition to see how much interest there were in flying different payloads across the UK, and fantastically there was 22 proposals received. Of those, 7 were down selected, and we started to work with those those different payloads to start preparing them for integration onto the satellite, principally using an Arduino-based computing system. Arduinos, I'm not sure how much they're used anymore. I feel like maybe other systems have, Raspberry Pi, for example, have kind of come in and replaced that. But they were fairly useful little introductory computing systems that could allow anyone to start getting access into developing computer systems and payloads for space. And we kept working, and we got to critical design review, which as the engineers in the audience will know is kind of the point where you're starting to cut metal. Everything is sort of fixed, except that not everything was fixed. We still had many issues with the software and the onboard computer. We had the challenge that one of the main systems, the supplier of that, had been bought out by MathsWorks and had moved their focus away from delivering the computer systems. We had problems with the launch vehicle that we'd selected because we were keen to meet the emerging deorbit guidelines to ensure that we were meeting sustainability requirements for space, and we couldn't guarantee that with the systems. And we had to make sure that there was a sufficiently mature ground segment in place such that we didn't just launch something and then not be able to communicate with it. And we had a review panel of some experts in the space industry from Airbus. That was a fantastic experience, but also incredibly challenging for a bunch of engineers who perhaps had never been in front of such a illustrious panel before with all their expertise. But we got there. We started to integrate the different payloads into the first buses, and with a Delta CDR. So we didn't pass the initial critical design review, but with a follow-up critical design review, then we were able to move forward and move into kind of the final preparations for flight. And as you can see, CubeSats have many uncertainties. Move forward, building the first ones, getting them integrated, starting to check the ground segment systems, starting to attach lots of wires, and then fortunately all the wires disappear as we start to kind of integrate for flight, thermal testing, vibration testing, RF testing, pattern testing, where we learned that we hadn't quite connected up the antennas correctly, vibration testing. And you can see some of the statistics in terms of effort of trying to justify this CubeSat system with the experts that we had around us, trying to ensure that we were able to deliver this, which was the flight model UCube-1, which ultimately was shipped out to Kazakhstan, which is a place called Baikonur, which is a Russian territory within Kazakhstan. Unfortunately now, given the war in Ukraine and Russian activities there, means that we're not able to use that, and rightly so. But at the time, then it was a fantastic place to visit, just to see as an engineer, the infrastructure that had been put in place. Pulled out the remove before flight pin, took lots of photographs of that to ensure that you could sleep at night knowing that the system was correctly armed and ready for deployment. Bolted it onto the side of a Soyuz, and there you can see it ready for deployment, and a few sneaky photos that we were told that we were definitely not allowed to take. Rushed back to the UK to a place called Gibraltar to get ready for the first operations. And we were told at the time that we would be getting a live feed of the launch. Just a few months previous to our launch, then there had been a major failure of the Russian Proton system. And so it wasn't worth the job of the director of Senki, the Russian ground infrastructure for launches, to provide any live feeds, just in case there was another example of a failure. And therefore we were just waiting for a blank screen. And this is what we got when the satellite launched, which made it quite challenging to know when the satellite was going to come overhead. And it was actually a tweet from a government minister that we could use to try and time the launch time and then work out when it was going to be overhead for our first contacts. And contact we did get with the first Morse code beacons. And it takes lots of expertise in RF to get contacts with the first satellites, particularly when you're trying to do it for the first time. And throughout kind of the UK, we were fantastically supported by a group called AMSAT UK. And if any of you students are interested in the RF side of communications and satellite engineering, then I would urge you to look them up. There's a fantastic wealth of experience for communicating with satellites in the UK through them. So not everything went to plan. We achieved many firsts with this first satellite, but we did have some issues such as periodic resets that occurred throughout operations. We had some challenges with the downlink transmission in that when we were transmitting, then we couldn't receive uplink telecommands because the strength of the RF signals coming down was just overpowering to the uplink signals. And because we were doing this on a very tight budget, there was no engineering model. So we struggled to manage to recreate some of the issues that we saw in orbit. But you know, you set your expectations and your success criteria in such a way that you're able to learn from those. And that would be a definite lesson learned. And we managed to achieve many firsts. So we managed to fly many different UK space technologies on a CubeSat, showed that useful science could be performed through the many different payloads, GPS, measurement, space radiation monitoring, and imaging from the systems. Showed the power of industry and university collaboration, and in some ways showed that we could allow rapid development, noting of course that there was a lot of exercise around that, waiting for launches, trying to knock on doors of politicians to get the funding in the first place, finding the champion in Airbus and so forth. And that had an impact within Clyde space. We were able to go from building these initial systems through into building now very sophisticated imaging systems like you can see on the right hand side there. That's from a satellite called Seahawk, which has created in a 3U CubeSat the same kinds of capability that was only ever possible in a 500 kilo satellite previously. So you can find out more information on that one on the NASA website, but a fantastic mission to see. Flying through now, because I see that I'm using up a fair amount of time and I want to give everyone time for questions, but then there was a period of kind of thinking about what happens next and how do we support the emerging kind of nano satellite and new applications, because we knew there was lots of different applications that were out there. At the same time, the satellite applications catapult was starting to emerge. So working with them on how to create new design tools to enable these systems. And looking back at kind of some of the challenges that we had and trying to ensure that we didn't repeat the same mistakes again, particularly around the different types of failures that you see and the different types of challenge that you see when you're trying to integrate a system quickly. But by 2017, then I had recovered enough from the experience that I was prepared to take another leap into the unknown and decided to set up my own business, Craft Prospect, around the moniker of smart, secure space. And among many of the different things that we do is look at how new technologies can be brought into the small satellite industry. And in particular, we have a mission called ROCS, Responsive Operations for Key Services, which combines some future quantum optical communications technologies with onboard intelligence to demonstrate future secure telecoms, and managing to build, again, very similar to the consortiums and the CubeSat research network that we had in the very early days of UCube1, a consortium of the willing that we're then able to move forward and deliver that mission. And the motivation for that mission is the emergence of quantum computers. And we know that with these quantum computers, some problems which are traditionally very, very hard for a conventional computer to solve become very, very easy. And we have a problem particularly in the encryption space where keys which are used for encryption become potentially very easy to calculate based on prime numbers, and therefore we need new ways to secure data. And what we're proposing is a system called quantum key distribution. It creates an alternate way of sharing secret keys, which rather than being based on prime numbers and mathematical complexity, it uses the physical properties of individual photons to encode a key, getting that down to different locations on the ground, and then using that key in conventional communications, such as through the internet. Space provides this perfect medium for that, because we can provide global coverage. And whilst we expect that space won't be the only medium through which future secure networks will be secured, it does provide the final steps towards doing so by providing this global coverage and also mitigating some of the challenges that you have on the ground. So, for example, photons that are used within fiber optic cables, for example, get attenuated, limiting the range. And with line of sight and passing through the dense atmosphere, then there's challenges of doing it through free space as well. Becomes part of any future cybersecurity toolbox. We're not saying that it's the complete solution, but it's part of the overall solution. And that will then feed into future markets where we see that the public key infrastructure, the prime number based infrastructure, starts to get suppressed as a result of more demands for higher levels of security, demands for forward security. That's the knowledge that maybe in 10 years' time, that data is still protected by the keys that have been delivered, which is not necessarily the case with our current systems. So our mission, it responds to two market needs. The first is in responsive operations, the need to provide accelerated and more intelligent tasking onboard satellites, and the second into cybersecurity, and allows us therefore to address these two different markets. And the reason for that is that we didn't really know how successful we were going to be as a business, and we didn't know where the market would take us. And so having these two different markets, emerging technologies, really has helped to grow the business and develop a series of new and enabling modular products. So here you can see some of those conceptualized in CAD model, and now thanks to the hard work of many engineers within the company, you can see them all integrated into the first flight models. So we have optical telescopes, we have beam steering systems to direct lasers, we have the quantum key source, which is a single photon emitting laser system, and then on the other side we have some forwards-looking imaging coupled with some back-end AI and machine learning systems. Excuse me. Some of the systems that go into that, I'll flick through these because we're running out of time, but beam steering, forwards-looking imager, an optical telescope, and it allows us to apply some of the model-based systems engineering techniques that we're looking for there. Oh, excuse me. I'll just take a sip of my wine. And here's an example of that system being used in orbit. You can see that ahead of us, we've got a scanner, which is looking for where the clouds are. We're then forming a link with ground stations where we're able to, as the clouds diminish. And we're starting to make more intelligent decisions about where to form links, optical links with ground stations. Here you can see the setup as it is at the moment, undergoing testing in our clean rooms. And as a result of this type of work, then we've been able to set up a business which combines a number of different areas, from mission and systems engineering through enabling technology products and into services. And 6 years on from starting that, we have a team of 21 engineers. We've worked with a number of different partners, as you can see on the right-hand side, and we've developed some new capabilities which are useful for the UK. Based in Glasgow, you can see the shipyards, the old drafting offices of the engineers, and clean rooms on the bottom right there, with a fantastic team here. I won't go into this slides too much, but what I wanted to focus on is over these times then, and reflecting on them, you can see that some things have changed and some things haven't. So what's unchanging? Well, delays. The engineering is full of delays, but if you go in thinking that something's going to be delayed, then it inevitably will. So you have to keep pushing forward. There's changes in funding priorities, and you have to remain adaptive to them. Excuse me. There's the engineering challenge, and that remains constant throughout. There's the need to upskill engineers coming into the industry, but equally, there's the amazing and supportive industry and people that you get once you're inside. And there's many surprises. COVID and the chip shortage just being some of them that are impacting us at the moment. And as a small business owner, there's also the fear. That's the fear of making payroll every month. So what's different between this time and the last time going through building a first CubeSat? Well, this time we're doing it with a CubeSat technology base 10 years on. So with UCube 1, then we were really focused on Morse code, trying to educate everyone about what a CubeSat is. I hope that pretty much everyone in the audience will already have been aware of these fantastic small satellites and their capabilities. We have UKSA, UK Space Agency programs to support CubeSats, both in terms of development and launch. And just recently, University of Glasgow received funding for their own mission, which is great to see. As a business, then we are an employee-owned business, which allows us to progress engineers as partners within the business, looking more holistically at how you can secure and deliver engineering challenges. And thanks to investment, we have a little bit more money in the bank to do all of this, thanks to employee-owned venture with capital for colleagues. So I'll just touch before finishing on the other thing, Omanos Analytics, where this is a completely different kettle of fish. It's a social enterprise, and it's really being driven forward by the three colleagues that you can see on the bottom there, Celia, Claire, and Dave, looking at how we can use space data in hostile and low infrastructure communities. So an example of the work here is a village in Guinea that had been displaced by mining activity of a large multinational. And the multinational had justified the loss of land to this village by taking imagery with drones and saying, well, this land that was lost was of little agricultural value, and therefore economically it makes much more sense that this is used by mining. What we were able to show is that the areas that were actually taken by the mining company was essentially the garden for the village. And we could do this very simply just by going back through the archives of Earth observation data. This was Landsat series, but just shows the potential difficulties that we will face as we enter a world in which data can be essentially weaponized between those who have access to it and are able to present it in certain ways, and communities who exist globally who might not even know that these data sets exist and couldn't access or interpret them, even if they wanted to. And so we need to be prepared for that and support it. And as you can see here, a quote from one of the NGOs that we've supported, that we were able to completely throw out the claims of land through a process that was essentially relatively simple. And so having proved the concept, we've now rolled out this to a number of different areas globally. We've also done work in Scotland, so I'd urge you to take a look at some of the case studies there. And really it becomes, how do we remove these barriers to accessing data and turning it into information that can be readily used by these communities, be they using media outlets or advocacy NGOs, or through the legal advisors, or directly within the community. And some of the barriers are awareness, access, understanding, and relevance. But the key thing here is I guess the link between what we can do with a downstream company like Omanos Analytics and an upstream company like Craft Prospect. And I think the link here is to scale this type of concept as a service and deliver it to more people. It requires a certain amount of computer intelligence, which is very analogous to the types of computer intelligence that we're developing for the upstream space industry. So some conclusions. Always keep moving forward. There's always going to be barriers, but you just have to keep on going. Work hard, play fair, and in doing so, good things will come. Build your networks and your team. Work out how you can fit into this. There's so many different opportunities within the space industry to just go for. And don't always believe what you read in the Daily Mail, because you never know when they've just phoned up a fairly naive young systems engineer who's quite enthusiastic about space. And on the right hand side, you can see some kanji that dates back from my time in Japan, and my supervisor there, who told me that a journey of 1,000 miles starts with the first step. So I'll leave it there and open the floor to questions. Thank you very much.
Well, thank you very much, Steve. That was great. It was really good.
Sorry, I started to lose my voice towards the end there.
No problem.
Not used to talking for so long.
Yeah. Cool. So if anyone's got any questions, just pop them in the chat and I'll read them out. First one we've got from Kobe, and it's, I have dreams of becoming an astronaut and I love anything rocket science related. I'm also interested in learning quantum theory. Is there any books or tips I should look at or do from now in the beginning of my aerospace course?
Oof. So I think, to start with, quantum technology is becoming a hugely influential domain, not just in the types of communications that I'm talking about, but in the computing side, in the sensing side. So I would urge you, if you're at the start of your university career, to talk to the university and find out what opportunities there might be to take courses in quantum engineering or quantum physics, because it's going to have a huge impact, in my view, in the types of technology that we see, not just in space, but in our lives in general. The types of orders of magnitude in terms of improvement in sensing is really profound. In terms of books, I can't necessarily recommend any books. I've had the good fortune to receive tutelage from some fantastic folks in Singapore, but as far as I know, that I don't think that they have a book out yet.
Great, thanks. And so Andy would like to know how you managed securing funding given delays that were happening.
So something that I didn't really talk about was how we structured the business, Craft Prospect and Omanos. So I started them both around the same time, one with a co-founder, Celia, and one myself. And the reason for picking kind of three technology areas in kind of mission engineering, in onboard intelligence and data processing, and in quantum technologies, was really because you don't know what's going to attract funding or the whims and the ups and downs of policy. And so it was kind of an engineering approach, systems engineering approach of thinking about redundancy to try and ensure that if there was kind of a disappearance of funding in one area, we had an opportunity somewhere else. Now, we were very fortunate that we managed to hit kind of the interest in artificial intelligence for Earth observation and the establishment of the quantum technology hubs in the UK, of which there's 4 in timing and sensing, in computing and communications, at just the right times. But that was more serendipity, and so we were able to grow quite quickly. But it does, anyone looking to set something up, I would urge to kind of not put all your eggs in kind of one basket and start thinking about how to have kind of a portfolio of different interests, just so then you're more able to deal with some of the ups and downs that inevitably come.
Great, thanks. And so within using onboard intelligence, how do you sort of mitigate the safety side of that? And are you able to express a bit more what you use it for?
Yeah, I went over that very quickly. And for sure, there are certain areas which can be addressed in the short term by that I mean perhaps non-safety critical systems. So the way that we're approaching it as a business is that we're looking to identify situations where onboard intelligence and more rapid data processing on board the satellite is going to deliver a value add which couldn't be achievable just by downlinking all of the information. So that could be in certain situations where you wouldn't have time to respond in getting a downlink, interpreting it, and then commanding the satellite again. But there's still a certain amount of hesitancy, and rightly so, in kind of the full adoption of onboard intelligence and the autonomy that that's going to deliver, because you don't want to mess up, especially on these multi-million, tens of £1 million missions. So CubeSats kind of provide a bit of a testing ground for some of these operational concepts, and we'll see them first of all be tested there, demonstrated there, and then we'll start seeing them get integrated onto these larger, more assured systems. And beyond that, then there'll be all sorts of questions around how do you trust the data that's coming down? How do you make sure that every step of the chain, from the sensor through the data processing through down to the user of that information, that there hasn't been any misinterpretation or tampering with that data sequence, because for a safety critical system, that then becomes really, really key. And we're working on technologies there for assuring that data chain.
Hi, you mentioned the need to upskill engineers entering. Is there anything specific you would look for or think we could do whilst at university to help with this?
So there's certainly kind of skills gaps, and this probably the one that we've seen most recently, and this is somewhat a result of COVID, has been like a lack of kind of hands-on experiences within universities, giving graduates the chance to kind of have got hands-on with some hardware, even if it's not ultimately ended up going into space, but having the confidence to play around with bits of kit. I think that's definitely something which we can encourage more within the universities, and hopefully with these new CubeSat programs which are being rolled out to universities, then that can provide kind of a bit more training there. I think finding niches at the intersections of different technologies. So we're very interested in artificial intelligence, we're very interested in quantum technologies, and we're also very interested in space. So space plus something else, I think, then becomes a really interesting proposition. What we tend to do with the team when they're coming into the the business, then we try and encourage them as soon as possible to get down in the lab and start breaking things, because I think that that's a really important experience, and the confidence to know that everyone goes through it, right? Everyone blows up a battery at some point, or breaks a sensing system. You need to take care, but not so much care that you never do anything. So don't let that become a barrier to kind of to your careers. But it's not just about the engineering. There's many other kind of supporting and important careers around it. In Omanos Analytics, then my colleagues there, none of them have an engineering background or indeed a space background. So Celia works in journalism, delivering and supporting journalists in hostile countries, which then becomes how we get contact into those communities and engage with those communities. Dave is a geologist, so knows a lot about geography and the formation of features on the ground, which can then be used for image interpretation. So I'd say it's not just about the engineering. If there's other people listening in, having different backgrounds shouldn't mean that you can't kind of come into the space industry.
Yeah, that's very important. So James said he's interested in entrepreneurship, and was wondering if you had any specific advice that you would give an engineer about involving yourself in business.
So I think one of the mistakes I would say that I made early on is disassociating myself from two kind of other areas which I think make up a more holistic engineer, and that's in project management and in business development. And it's very easy for an engineer coming into a business, and perhaps rightly so for the first few years as you're learning a bit more about your discipline, to focus just on the engineering. But to me, being a well-rounded engineer is being able to secure and deliver an engineering capability. And that means being able to go out and present and to talk and explain your value proposition to stakeholders, and also being able to get involved in the project management and understand the importance of deadlines and budgets and all of that side of things, which sometimes as a young engineer I probably overlooked the importance of those areas, and I think that sometimes in doing so you miss out on the opportunities that kind of come, and so therefore I would say for any kind of entrepreneurial minded engineer to spend a bit of time developing themselves in those areas, not just in the engineering, so that they're then ready to kind of go out and they can build networks and teams to help them to deliver the vision.
Thank you. And are there any unexpected skills you needed to sharpen when progressing through the space industry?
Always. I know I wouldn't necessarily say that I've finished learning. I think, but it's now for me, I guess the biggest thing is learning to transition from being an engineer to being a managing director, and not getting so involved in kind of the technical every day, and allowing my team leads who are fantastic to kind of take on that part and start looking at kind of the next level. So for me, the challenge now and the skills that I'm trying to learn is more how to fit in with the wider space industry. So I've recently taken up a position within UK Space as the chair of the SME committee. So understanding the challenges that not just my business, but we as an industry face, and how we can look to start solving those. So yeah, I think there's always new things to learn at different stages in your career path. Yeah, I'm not sure that I've answered that question particularly well, because they were unexpected, and I think that they'll be different for everyone, but that's just where I am.
No, that's great. That's really good. So Yeah, we had a question from Mika on any systems engineering books, and one of our co-chairs, Lucy, has just put in the chat the link to the NASA Systems Engineering Handbook, which gives a very good overview for anyone else that is wondering about that question. And we're just sort of running out of time here, so I think we're going to wrap it up there. And thank you very much, Steve, for your great talk and answering all those questions.
Sure. Thank you, Charlie. Thank you, Lucy, and thanks everyone for listening.
And
Thank you so much, Steve.
Oh, sorry, Lucy.
Sorry, I just want to say a huge thank you, and I'm sure all the audience would like to thank you as well, Steve. If we could do you a huge round of applause, we would definitely be doing one. So anybody who can work out how to do that in the chat or with a reaction, then do it now.
And in silence, I will take that applause.
There's lots of thank you messages.
Yeah, I can see them. Thank you, everyone. Yeah, and yeah, just keep going with whatever studies or whatever visions that you have for the future, because yeah, it's a great industry to get involved with.
And for anyone that would like to provide a little bit of feedback to the webinar, I've put a Mentimeter poll in the chat. So be grateful to anyone that can fill that in.
Thank you so much, and watch this space for more exciting talks.